Let's go to LeetCode 2019. The score of students solving math expressions. They give us a string S and integer array answers. And let's count the score of the students. So what does this one mean? Is that if this S is math expressions, and it contains plus and the multiple sign, and also digits 0 to 9. And the students give integer array answers. So the thing is that so we look at this answer. If in any of these answer they are correct, just for example, we have 7 plus 3 multiple by 1 multiplied by 2, right? This equals 13. If there is an answer equals 13, then we are going to add 5 points. But if in our case, the answer is not 13, but it equals some kind of parentheses added here. For example, this is 10 multiplied by 1 multiplied by 2, right? So that is 20. If in this case, then we're going to add 2 score 2 to the final result. And if the answer is not of any parentheses added, or the correct answer, for example, it goes to 1000, right? So this is not in any of correct answer or add a parentheses, the answer not in the set. Then it adds 0 points. So it asks what's the total score the students can get. So this question can be thinking about it is composed of 2 questions. One is if we have an expression like this, all right, we calculate the result. So this is just the simplified version of calculator 2, right? Calculator 2. Another, so this is to calculate the correct result. This is calculator 2. Another question is that if we add multiple parentheses somewhere, right? What can we get a set of integer, right? Of the result. So what is this question? This is question 241, different ways to add parentheses. So you'll see this one is different. It is also a simplified version of 241, right? Because for us, um, our number only have 1 digit, and also has only plus and multiple sign, right? And there is no minus sign. But the way we do it is the same. So we can use the code of calculator 2 and the code of 241 to solve this question. But use the code of these 2 directly, it will tell you. So the only thing to simplify to get the path, right? So let me show you what I do. Is that because we'll see these answers is going to be less equal to 1000. So for 241, when we add the result, right, we just check if this result is smaller than 1000, then we add it to our result. Then it can pass. We just add one condition, so that the set is not that big. So we can almost use the code of calculator 2 and 241 directly to this question to solve it. So let me show you the way I use the I just use copy the calculate tools code and also 241's code. But this one I change this to set so that it will be easy check. And here I add one condition. So um, we know the way we how to solve this question. We can write the code. Um, so I'm going to uh, change this string to be char array. Because for the question 241, right? Um, anyway, it will have the space more than O n already, right? So change this to char array. It will not get the space complexity worse, right? Of course, if the question is only calculated two, don't change it to char array because we can use constant space for calculate two, right? Then what we have is int n equals array dot length. For this memo, we're going to create a memo, right? So we are going to use a map string and set integer memo equals new hash map. So there are two ways to for 242, right? So that is we have a start and we what we do is that we iterate trying to find the separator of signs, right? And get this part's result, this part's result. And if it is add, just add for each values in this and for each in this add to add the result, right? If this multiple, just each value here, each value here, just multiple, then add to a final result and save it to memo, right? And we can have the memo to be string and set because it is possible, for example, a plus, for example, we have multiple comma strings. For example, 2 plus 3 plus or multiplied by 5 and plus 3 multiple by 5, right? If we have multiple things like this, right, we'll find if we have a lot of repetitions, then the way we can save the this will be better, right? Other and also we can have the memo. There are two options. That is, for example, the set integer, um, which have a start end, right? So we can have option two is um, equals new set and right. Doing like this, the good thing is that advantage is there is no string operations, right? So it may be faster, but the thing is that a disadvantage is that if there are a lot of repeatable strings, the second way may not be efficient. But I test that too. The result are actually almost the same. So um, I'm going to use the first right now, and I can change this a little bit to the second version. Um, so so what we have is we are going to have a set of integer answers equals DFS array from 0 to n minus 1, right? And the memo. And we also needed the correct answer, right? Correct answer. That is the basic calculate tool. We use calculate as we can use array, right? Calculate array. And so we are going to have result equals 0. And then for int v in answers, so let's say if v equals correct, then we're going to have result to the plus equal to 5, right? It means this is the correct answer. Else, if we're going to have set let's say answers contains 3, then we'll have results to the plus equal to 2, right? In the end, just return result. So the first thing I want to write is the multiple ways to add princess. So we write the DFS. Okay. So we are going to have a private set integer in DFS array, right? And int start, int end. And I'm going to use a map string and set integer mem, right? So what we have is, so we know this string key will be new string array from start and end minus start plus 1, right? So we're going to have set integer result equals new hash set. And so what if start equals n, then we're going to have results. For this one, it simplified us because the digits only one digit, right? We just have array start minus 0, right? And we can also memo put this key as the result and then return result, right? So well, right. If memo contains key, just return memo get key. And we'll write we iterate the sign, right? So for int sign equals start plus 1, sign smaller equal to end, and the sign should plus equal to 2 every time, right? We iterated the separator. So let's say set integer let the result equals DFS array start. So the end will be the sign minus 1, right? And memo. And we'll set integer write the result equals DFS array. This will be sign plus 1 and end in memo, right? So what we do is that for every int L in left result, for every result in right result. So we're going to have int v value equals so if this array sign equals plus, right, then that will be L plus, right? Otherwise, it will be that is multiple by right. So well, so the difference between the add princess is that we need to add this kind of condition if v smaller equal to 1000. Otherwise, it will be TRE, right? So that for the checking, this one we'll always get our results set to be a smaller number. Otherwise, if it's a bigger one, every time for we iterate the numbers, um, because the time complexity for this one, right? So we'll iterate this kind of n and n, right? And if we limit this kind of size, um, if we limited this kind of size, uh, we what the start end n is n square, and the separator this is the n, right? So this n third, and this there is this one, for example, the size is k, and this is k, right? So the time complexity will be O n square k squared, right? So we'll see this size um, matters on our question. If we don't limit it, it will tell you. So if we say this k, v is smaller equal to this one, so this k is always smaller equal to 1000. So that this one will no bigger than 10 to the power 6. Um, so if we do this kind of sets, we will actually consider this one to be constant. Um, Otherwise, this k will apparently affect our result. If this is so very big, it will TRE. Um, so actually, in our reality, this k will not go to 1000. That will be too huge, right? But if we add this one, because the thing that this is just the calculation result for the string, so in reality this k will be very small. Well, but we don't add this one. Um, this kind of set will be very large size. It will be TRE for our question. So this will be the thing added to the question at the princess. So if this one smaller equal to this one, then we're going to have result add v. And we also need to save this one to our memo put key result and the return result. So this is the first part. And the second part is the calculator, right? The basic calculator. Let's write the basic calculator question. So we change this one to cherry. Um, we'll have the char sign equals plus sign, right? And as we know, we can use a result equals to 0 and a parent equals to 0 and last equals 0. And let's have n equals array dot length. Okay. So what we do is that for int I equals 0, I smaller than n, I plus plus, right? So of course, here we can use the stack to solve the question because our space complexity will already have this map, right? This map will be O(n) square, and for each one they may have k, right? case size. So each already worse than ON, right? So if we have a stack, use a stack way to solve the basic calculator, will be it is fine. And just a personal like you can use the last uh, variable, right? So as we talk about the basic calculator, we have the strings a plus b multiply c plus d, right? So what we do is that we push this a to the stack and push b to the stack, and we see here, right? So the sign here, we see this sign, right? So this previous with plus, so a can we can add a, right? Let's don't use don't not no the stack way is that we push A, we push B, and when go to next sign, we will find the previous sign is this sign is plus. So what we do is we'll have B pop B and multiply C and push to the stack again, right? And in the end, sum up all of the values in the stack, and we can also use a last variable, right? So that is we add a last and a plus sign in our expression, right? So a plus b multiplied by c plus d, right? So this last is 0, and this is our sign, and we iterate I here, and we see another sign, right? Another sign that we find the previous is plus or minus here that can only be plus, right? So that add a last. So initially we add a 0 here, and then our last will be our a, right? And also we change our sign to this kind of signs. So we go here, we find another one that is a multiple sign, right? So that we find the sign is plus. That means we can add a to our result. So our sum should plus equal to a, right? And we go here. We have last should be b. Last is here, and we go back and b multiplied by c plus d, right? So if we go to d plus this plus here, right, we'll find the previous sign. It is a multiple, right? Then what we need is we should have the last, update the last to this part. That will be last will be multiplied by c instead of add to our result. And when we go through the end, right, we find this one is already sign is a plus. Then we are able to add this last. But when we have another step added to update this last to be the last value, we should also add this. So um, let's write code for this. Um, so we'll have char c equals array I, right? And so we'll say if character is digit c, then we're going to have current equals current minus 0. So what we do is that if I equals n minus 1, or for this character is the character as well, right? I equals plus, or c equals multiple, right? So for this one, there are only two types of characters. So we'll say if sign equals plus, then we're going to have result. That means we can add it to last, right? Because for the uh for the if a sign is already plus, that means this last already been calculated, and we should be able to add the last, and we're going to have last equals current, and we'll say else, right? Else we'll set last should multiple equal to current. And we just need to update line because say, right, we for this current we don't need to set a value because every time we just we need to recalculate, And in the end, um, we still need to have result should add equal to last and then return result. So doing like this calculation is O(n) time complexity and O1 space complexity. Let's run the code. There is some problems. Um, let's check. Let's print with correct. So this will be 13, right? To to we'll see. This is our calculator too seems not right correct. So let's check sign current last sign. Here the sign should be updated as be update here, right? Instead of should be update here. That is here we met the sign, right? So for the n-1, because this sign will never be used in the future calculations. So this set integer still be it is okay, right? Calculator. Let's see, this calculator didn't calculate correct. So let's still look at so if is digit C, then if this is n-1 or this is plus or this is multiple. So if a sign is plus, so this will add equal to last and last. This will be C. And the result should add equal to last return result. This correct is not calculated, right? Let's still look at 0 radon length. Calculator is digits. Current. Last add equal to last. Current. And we still didn't get this one to be correct. Calculator. Result. Current equals last equal to 0. If this is digits, this is C minus 0, right? So, so, um, so this is basic calculator 2, right? As we mentioned, for this kind of memo, we can save string. We can also save I and J index pair, right? Um, let's submit this first. Oh, this is not good. Actually, I have 340 something a moment ago. Okay, so whatever. So the thing is that um this kind of memo we can also uh save as as the index pair instead of a string. The advantage is to use IJ index pair is that because the convert to string, this operation is kind of slow. The disadvantage is that for this map, right, if we have some repeated pattern, for example, 1 plus 2, and up another place 1 plus 2, if this appears multiple times, then we can reuse. So both have advantages and disadvantages, right? So also, so let's change this memo to be another approach. For example, we have use a set integer um, memo equals new set and right. So what we do is that this one instead of use map, you can have set integer at this right. So so we don't need key anymore, right? We just store those kind of start and end. So if this one equals last, then um, we'll have add result add this. And what we need is that we just need to put memo start and equals result. Right? So we'll say if memo start and doesn't equal to null, just return memo start end, right? And so here this will be same, and we'll write memo start end equals to result. Right. So that change will be very minimal. So let's try to see which one will be faster. Okay, this one seems better. Um, but the thing is that actually doesn't affect too much. So we can also have memo which is just store the start in the index, right? So there are two options. So let's analyze the time complexity and the space complexity. So we are for the time complexity, right? So there are two parts. One is calculator, two is the time complexity and the space complexity. For calculator two, right? This time complexity will be O n, and space is constant. This part, and we'll see because actually our DFS and the memo this has a bigger one. Actually, the calculator two doesn't affect our results. So we'll see this one will iterate start end. This will be n squared, right? And we are going to iterate the separator. So it's O n cubic. And if we have a stack size set to be k, so will be O n squared k squared, O n cubic k squared time complexity, right? We can consider this as constant. And in both solution, right, the space will be this will be n squared kind of case, or this one will be n squared kind of case, right? And then the value will be k, right? So k can also be um, get rid of. So will be O n square space complexity. And we can also change this to Python code. Um, so we are going to have n equals the length of string. And we are going to, in Python, right? Of course, we can also create a map or those kind of set array. But in Python, we can have this cache annotations for the DFS and the memo. So we can write def um, DFS start is the int and the end this is the int and this will return a set. So what does this one cache? It is cache a pair of start A, right? So it is pretty much like we cache set integer start n. It doesn't cache the string, right? So when we write this, we'll say if start equals end, then um, return this kind of set. We change this value to be int. So will be s start. Okay. Then what we do is that result equals set. Then for sign in range start +1 to end and 2, right? We're going to have left result equals DFS start to sign -1 and the right result equals DFS sign +1 to end, right? So what we do is for left result, for R in right result, we're going to value equals left plus right if S sign equals the plus else that is L multiplied right. So we need this condition. If value is smaller equal to 1000, then we're going to have result add value. And in the end, we need to return result. Yeah. So this one we don't need to put a set array here. So for our main function, let's write the calculator to in a separate def function. Um, um, and we have a correct equals self dot calculate s, okay. And we'll say that is answers, right? Equals TFS and -1. So what we do is that result equals 0, right? So for v in answers, if v equals correct, then we'll have result should plus equal to 5. Here we'll write else if a v in answers, then we're going to have result should plus equal to 2, right? And in the end, return result. And we also need the basic calculator. So let's define here calculator self is str, which will return integer. So we'll say we have sign equals let's have sign result current last. We need a let's have an n as well, right? And equals sign is plus result current last n is the length of s. So what we do is the for I in range n. What do we so c equals si, right? So we'll say if si is digit, then we're going to have current because let's change this one as int. Then we'll say if I equals n minus one or si equals plus sign or si equals multiple sign, right? Then what we do is that if sign equals a plus sign, we are able to add a result. Result should plus equal to last, and last equals current. Then else again have last should plus equal to current, and we always have sign set as SI. So this is SI. So and doing like this, we still need to add the last variables, right? So we'll have result should add equal to last, and in the end, return result. Okay, so this will be the code.